Hi everyone, my name is Ksenia and I've been studying chemistry for over 15 years. On this channel I am explaining the most important chemical topics briefly and in simple words. And in this video I will talk about how to write the electronic formula of an element. Today's video is practical. I will go over several examples. If you are completely new to this topic, I recommend to watch another video on my channel where I explain how to write the electronic formula of an element using the periodic table. Let's start with sulfur. Sulfur, an element of the third period, meaning that sulfur has 3 electron layers. Its atomic number is 16, indicating sulfur has 16 electrons in neutral atom. And now let's arrange these electrons by levels and sublevels. We will begin writing the configuration by moving from the beginning of the periodic table. In the first period there are 2 s elements, so we write 1s2. Then in the second period we see 2 s elements again, so we add 2s2. Next are the p elements, 6 in total, so we add 2p6. Moving on to the third period, which starts with 2 s elements, we will write 3s2. Then among the p elements we find sulfur, which is the fourth p element. Therefore, at the end we add 3p4. This gives us the electron configuration, the sulfur. Now let's move on to the d elements and start with iron, which has 26 electrons. I won't dwell on the electrons of the first 3 layers. It's the same concept as in the previous example. The first 18 electrons of iron have the following configuration: 1s2, 2s2, 2p6, 3s2, 3p6. Then we move on to the element of the fourth period and write 4s2. After them come the d elements, including iron with 6d electrons. Here it's important to remember that d elements fill the penultimate electron shell. So we add 3d6, but no 4d6. And that's it, we have the electron configuration of iron. Now about exceptions. In the d block of elements, 4th and 9th element have a special configuration. In the fourth period, these elements are chromium and copper. Initially, the electron configuration of chromium is the same as that for iron. That is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And then we should add 4d electrons on the third level. But there is a twist. There are 5 d orbitals, which you can imagine as empty slots where electrons are placed. So for the atom, it's energetically favorable for each slot to have an electron. Therefore, chromium has 5 electrons in the d sublevel instead of 4. And this 5th electrons doesn't come from nowhere. It jumps from the order 4s sublevel. Thus, the overall electron configuration of chromium looks like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. And copper has very similar situation. In general, it should have 9 electrons in the d sublevel, but it turns out that a fully filled d sublevel is energetically favorable. Therefore, just like in chromium, 1 electron from their 4s sublevel jumps to their 3d sublevel, and the electron configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. In general, remember that for the 4th and 9th element of the d block, 1 electron from the order s sublevel jumps to the penultimate d sublevel, because this is more energetically favorable. Let's go over one more example. Krypton, an element of the fourth period with 36 electrons. We already know that the first 18 electrons are arranged as follows: 1s2, 2s2, 2p6, 3s2, 3p6. Next we have 2s elements of the fourth period, so we will write 4s2. Then come 10d electrons, but remember that they are on the penultimate third level, not the fourth. So we add 3d10. Then there is nothing complicated. It is a block of p elements and krypton is the last one with 6 p electrons. Therefore, at the end of the configuration, we will write 4p6. This means that krypton has a completely filled valence shell, which is why noble gases rarely undergo chemical reactions. That's it for today. If you found this video helpful, please like it. It helps me to grow my channel and create more educational videos. See you next time.